Okay, so welcome to part 5 of our series of rewriting this shoot 'em up from KidsCanCode using Lua, Monogame and Pygame. I would encourage you to watch the Lua version, which I've already put on before you watch this version. This is the Python version using Pygame. We're combining part 5 and part 6 in one here. Now, I'll just show you what the end result of this one is by hitting that, and of course, as usual, hoping it doesn't destroy me. So what we've got this time is I can fire these bullets up, which, as you can see, consist of a yellow rectangle with a red circle at its tip. And you'll notice that each of the mobs is consisting of various sizes of meteor, and then with a blue rectangle that keeps the horizontal and vertical position, and also a rotating green rectangle which rotates along with the mob. I'm assuming that it changes sizes because the rectangle that contains the mob, as it's rotated, also changes its size, although we don't get that in the Love2D version. But the whole purpose of this is to show you where colliders are and how to interact with them, and how you can draw rotated rectangles in Pygame. Okay, let me close that off now. So I thought, right, I want to be able to draw let's just drop this out of the way for a second. I wanted to be able to draw these rotated rectangles. So of course I went on to search to find out how can I rotate a rectangle. So this was Stack Overflow. So there were some ideas here, but basically it kind of boiled down to this statement here. You cannot rotate a rectangle drawn by Pygame Draw Rect. You have to create a transparent Pygame surface and rotate the surface. I thought, okay, this is obviously going to be more difficult. There's some ideas here, but they all look fairly complex. Then I thought, okay, how about we don't try and draw a rectangle. This is the Pygame reference here. Instead of drawing a rectangle, is there any way we can draw it in a rotated way? Apparently not. So you can change like the corners to put various radiuses in the corners, which is okay, but no way of kind of rotating it. So then I thought, oh, well, if we can't draw a rectangle, we don't seem to be able to manipulate the graphics as we do in Love2D for sort of push and pulling things on. Why don't we draw a polygon instead? Then that way we're still drawing a rectangle, but we're describing it as a polygon so that we can specify the corners of the rectangle so that it can draw it by drawing a polygon. So that looks okay. So that looks possible. Now, how on earth do you calculate what the polygon should look like if you've just taken a normal rectangle and rotated it? So, of course, that was my next search. So let's have a look. So I did a search for calculating the vertices of a rotated rectangle, and I found this one. Now, this is C++. Looks fairly complex, but not too bad. There is some maths there. You go through it and you read through it, and there's some various ideas as usual. And then I just noted down here, kind of almost by off chance, my code should actually work. There's a working Python turtle code at this paste bin, and I thought, oh, that looks good. We might be able to get something from that, because this looks fairly complicated to try and convert to Python. If we've got a Python code already, that would be brilliant. So I clicked on this and went to the paste bin, and sure enough, it's a relatively simple Python script to rotate our rectangle and draw the rectangles. So I copied this from pastebin and put it in a file, and I called it just rotate rectangle here. So here it is. That's exactly as you saw it on that paste bin. I will run it, but it draws on my other screen, so I'll have to kind of drag it across as quickly as I can. So let's see if we can do this in one hit. Get that. Yeah, okay. So as you can see, we're drawing this rectangles, and it is indeed rotating the rectangle, so it's doing the job. I believe it stops any second now. So what we're wanting to do basically is to kind of get these vertices where the corners of a rectangle that are rotated are sitting, and reproduce that in Pygame and indeed in Monogame. So let me shut that one off. So I've added it to the mob in section 5. I've added it to my mob class. Just increase the font a bit there to see if we could get it to draw. So my first effort was this one here. So I called it get rotated rect 1, and I've passed it self, width, height and angle to try and replicate what we had in this original rotate rectangle. Obviously we're not, this is all stuff for the turtle, we're not really interested in that. So basically this is the bit that does its job and gives us this set of coordinates x1, y1 and so on. So this is the first effort. So we have to import the degrees, radians, etc. from math. Then we get the R, I think, is kind of the equivalent of a radius. Although we've got a rectangle, it's like the center point of the rectangle is done by this piece of maths up here. Then these are the methods of working out where the points of the rectangle are. So we're doing this little bit of maths up here first, and then after we've got these 4 kind of values, theta 1, 2, 3 and 4, we're then adding on the rectangle angle that we've set it at, and then we can produce this set of 4 points by doing this bit of maths down here. And then I'm returning a list of tuples. So each of these tuples is a vertex of our rectangle that we're trying to rotate. So that should work. So I've passed in the width and height of the rectangle and the angle that it's rotated in. So if I come back down to the draw section, I'm going to undo that one, block that one off, and we'll do it with the first one. So this is, we're going to now do Pygame draw a polygon using the screen as we did with drawing the rectangle. I've chosen my color as green, and then I'm calling this function self get rotated rectangle, passing into it the center of the rectangle, x and y, and the rotation. Okay, so let's see if that works. So we'll hit the save button, go back to this and run it. Well, kind of. We've got our mobs falling here, and we've got a bunch of rotating rectangles. So we're stepping in the right direction, but obviously what I've not done is I haven't set the starting position of these rectangles, so they're just starting at 0, 0, presumably up here in the corner. So anyway, it's a step in the right direction. So that was effort 1. So going back to the mob, so let's minimize effort 1. Effort 2, again we're passing self, but this time I'm passing the rectangle and the angle, because why work out the width and height before passing it in? We can just get it from the rectangle. Okay, so again we've got the import of the math things here. Then I've put a W as the rectangle width and H as the rectangle height, and then that does that working out of the center. It then does the little bit of maths here. Then we're adding the angle, And then we're doing that. So it's basically the same as it was before. It's just that I've simplified it a little bit by passing in a rectangle. And again, we're giving a list of tuples, each one being the x1, y1 coordinates. So let's change that. The point I wanted to get with this one is, look, I'm adding here the rectangle center x and center y into these calculations here, which we didn't do. If I just plus that up here. So we were just following the formula as we were given for the turtles, but it wasn't taking into account that we need to update the sort of starting position, which I've now done here. So we've added the center x and center y. So let's go back down. We'll comment out this one, and we'll now use my second one, which is where, again, we're using the self.getRotated rectangle, passing in just a rectangle this time, and the rotation and 1. So we'll save, go back to this, and see what the result is. Okay, now that's looking better, except there's a big problem. If we take this one here, you can see that this green rectangle is rotating clockwise, but the meteor in the middle is rotating anti-clockwise, and it's the same with all of them. If we can get one on its own rather than a multiple set. This one here, look. So we've got the green rectangle anti-clockwise and the mob clockwise. So obviously there's a mathematical problem here in that something needs to be reversed. Okay, no problem. So we'll shut that off and we'll go back to this one. And again, I looked up through here and there were some comments further up, and it said, oh, how would this formula be to rotate clockwise? Then it says, oh, forget my question, just make the angle negative. So just by searching the comments here, I didn't need to do any kind of severe mathematical problem working out. It just says here, make the angle minus. Of course, all you mathematics people will know this, I'm sure. So I thought, okay, great. So let's go back to my code. Go back to mob. So we now need to do another version, which is version 3. So we'll negate that one and that one. And this time I thought, well, why am I passing in these values when they're already part of this class? We already know the rectangle, we already know the rotation. So we don't need to pass anything. We can just, so this is version 3. So again, I've got to just return a set of vertices, which I can, as I've done here, but I might as well declare them at the beginning. So I've got this vertices as an empty list. Then I've set W and H as self.rect width and self.rect height, and then the angle is self.rotation. So I've just taken basically the same values as we had in here, width and height, and then we've got this angle, but using the built-in properties of this class, so the self.rect and the self.rotation. Again, we've got this r, square root of that lot. Then we've got the working of it out here, but this time what I've done is, instead of doing the maths and then kind of having an x1, y1, I've done it so that we are appending a math.vector2. So where did I get that from? Again, if we go back to Pygame, you'll notice it says that when you're drawing a polygon, you can draw a sequence of 3 or more xy coordinates that make up the vertices of the polygon. Each coordinate in the sequence must be a tuple stroke list stroke Pygame math vector 2. Math vector 2. Right, okay, so this is what we're going to be using. So what I'm doing is appending to my empty list of vertices a Pygame math vector 2, and then putting the maths that actually calculates those, including the offset into there, and you'll notice that here I've put θ1 minus equals angle, minus equals instead of plus equals. So that will compensate for the fact that they were rotating the wrong way round. So version 3, we've got minus equals with the angle, and then we're appending each of these vertices to our list, and then we're just simply returning the pre-compiled list. As you'll notice, there's quite a lot of repetition in here, so I'm thinking, oh, I'm sure we can do better than this, but that's for the next version. So let's test this one out. So we go down to here, we now hash out that one, and we unhash that one, save it, go back here, run it, and again we've now got our rotating rectangles, but at least now they are rotating in the same direction as the mob. So this mob is rotating clockwise, so is the green rectangle. The bullets of course work as they did before, and if I get a bullet where the round circle head of the bullet interacts with the round circle of the mob, it will destroy it. If I can miss it, I'll try on this one, so we'll try and get it as close as I can. Anyway, if I miss the circle, then the mob is not destroyed. So it just makes the accuracy of our collision detection using circles a little bit better than it does with using the rectangles, which was the whole purpose of this section of the tutorial. So we've now quite successfully got our rotating rectangles. But I still didn't like the code. It looked kind of clumsy and unfinished. So we've now gone on to version 4, which, let's just shut these off. So that's version 1, version 2, version 3. This one, I didn't call it version 4 because this is the one I wanted to finally use. So it's just called get rotated rect with passing in self. And here what I've done is I've got the R using this formula as before, but of course I've, if I just expand that one again, I did it before by kind of having variables for WH angle and then passing in those variables to math square root. This time I've put the self.rect width and everything in, so it makes that line longer, but we're not kind of using any intermediate variables. We're just working directly with the rectangle's width and height. Then this one, I've done a list of thetas. So we had θ1, θ2, θ3, and θ4. So I've created a new list called thetas with a single element in the list, which is this one here, again using just the self.rect height and self.rect width, which is the equivalent of this line up here. Yes, this one. So we've put that one in using the math degrees, whatever, so it's quite a long line. And then I've added in one hit using the extend property of a list to add multiple items at once. And I've put in to the items I've added here are 3 separate items in our list. That's this one, and this one, which is the equivalent of these here. And I've also combined it with the rotation. So I've added in this one the theta's 0, which is this, minus a self-rotation, followed by theta 0 minus 180 minus the rotation, and so on. And then finally we need to correct theta 0 by removing the self-rotation or minusing self-rotation from it, so that we've kind of combined these two into one list. Then I've declared the empty vertices list, and then of course we can use a for loop now. So for theta in thetas, our list, vertices append, and then of course we've just got the word theta in here, plus the self-center rect center x, plus self-rect center y. So inside this for loop, we've added our 4 vertices that we were doing up here. So that's kind of got rid of the repeated code. I'm sure some of you geniuses can come up with doing the whole thing in one line with list comprehension, but this has been done as a tutorial to see how it's working, and mainly to show, if you've got a problem, how you can find the answer to it by sometimes looking at something that is not blindingly obvious, such as finding that paste bin thing with a turtle in it and adapting that, and then thinking, okay, how do I make it rotate the other way, and just seeing a casual comment in one of the posts. So sometimes it's not as obvious as it was. So that's the one I shall now be using. So if we now blot out that and undo that, in the my repository for these, I've not put all these kind of sub ones in there, so you're very welcome to copy them if you wanted to see how they all work. So I've only actually included this final version, and that's the one that runs it. So that will now draw the polygons. So let's hit the save button on there, go back to there, and there we are. We have our working thing there. Let me show you now just the rest of the code that deals with our rectangles. So if I just increase the here. So the collisions are dealt with a new circle collider up here. So similar to, this is the one that we were using for our rectangles, which we've been using so far. So this is a similar thing. This is just called circle collides. Again, I looked it up online, see what I could find, and found this, which is quite useful. Again, a little bit of simple maths, and then it's either going to return true or false, depending on whether the circles are close enough together to actually be colliding. So that's the maths behind it. And therefore I've changed in our mob bullet collisions and mob player collisions, instead of using the rectangles by using destroy equals collides bullets and mobs, we're using destroy equals circle collides bullets mobs, get their circles rather than their rectangles. Same with the mob player collisions, we're using the circle collides mob circle player circle rather than mob rectangle player rectangle. So I've left those kind of hashed out so that you can see what was working. We're now using circle colliders, not rectangular colliders in those. The loading of the images, let's just go through that. So our load images has changed now, in that we are creating this list of meteors, which is the list of all the image files which are in here. Again, this is far more than we need at this stage, but I've just got a kind of comprehensive list. It's basically these ones. I won't remove them at all. These ones here, meteor brown down here, so there's 7 of them. So we're creating a list of all their names and then using a for loop to append them to a list of images with those each of those 7 individual images in there. And then when we create the mobs down here, in the Lua version I appended an individually chosen random image. Here I've done it slightly differently. We're appending the entire list of meteor images, and in the mob class, go back to that, there we are, we're choosing using random choice. Lua doesn't have a random choice, you have to do it in a more lengthy way. So I thought it was just easier to pass in the entire list of images here. And then also with the Pygame way of rotating the images, you have to make a copy of it and so on. Please look at the original, if I can find it, this one. Please look at this one and the following part to get the methods of doing that. Because it goes into great detail about why you have to make a copy of the image before you rotate it and use the original copy as you are creating your rotations. Otherwise the whole thing just goes bizarre and corrupts and runs out of memory and all kinds of daft things happen. So I'm not going to go through it here, but I've just followed the same code as the original tutorial. We're making a copy and then getting the rectangle from the copy and then rotating it from there. Okay, so I'll leave you to play about with those, and we'll move on to the Monogame version next.